Okay. Okay. Good afternoon, ladies and gentlemen. And let's start it. My name is Chiaho from NHRI. It's my really great honor and pleasure co-chair this section with Professor Tianhong Li. This section we will focus on have the 4 distinguished speakers, and they will focus on the journey of identify an undruggable target and also finally become a most hardest druggable targets. That's the Ras. So the first speaker, it's my great honor to introduce the Professor Chiaho. Professor Shih, I believe that everybody know him very well. He is currently the professor in the Graduate Institute of Medicine in Kaohsiung Medical University. Professor is really expert with both the molecular virology and also molecular oncology. So it's across the different area. And also, if you have ever read the very famous book for the Bob Weiber, is the Racing the Beginning of the Road, the search for the origin of cancer. So if you have ever read this book, you will find the key person who identified the oncogenes. And today we are very lucky to have him in person tell us the fascinating story. So he will give us a historical narrative on the genetic basis of cancer, how to identify the undruggable target Ras. Let's welcome Professor Shih. Thank you.
Thank you very much for the very kind introduction. I would also like to thank the organizing committee for the invitation. Okay. Yeah. In my talk today, I will summarize 3 papers from my PhD thesis. The work was performed in Robert Weinberg's laboratory at MIT. Bob, in his career, received numerous honors and awards. The highest honor in the United States is he received the 1997 National Medal of Science from Bill Clinton. And so today, Bob remains a major player in the EMT and metastasis field. Okay. This is Bruce Ames. He made his fame by inventing the Ames test. And because of the simple test and low cost and rapid, these days we all have the concept that a lot of mutagens are carcinogens and a lot of carcinogens are mutagens. About 100 years ago, a British scientist, Fred Griffiths, he observed the in vivo bacterial transformation in his animal model of pneumococcus. And he speculated that the transforming principle could involve something that can passage the transform phenotype from, I don't have a pointer here, but let me say here. So he speculated that there's a transformation of the smooth capsule virulent strain of pneumococcus to the rough capsule non-virulent strain. But at that time, they don't know if the transforming principle is DNA, RNA, or protein. And it was about 16 years later that Avery at Rockefeller University demonstrated that the transforming principle is DNA sensitive and protease resistant. So it established the concept that hereditary material, at least in bacteria, should be DNA instead of protein. And this is against the concept back in those old days. Yeah. All right, thank you. My first paper is titled Passage of Phenotypes of Chemically Transformed Cells via Transfection of DNA and Chromatin. I cannot really control it very steadily, so let me forget it. The paper was communicated by David Baltimore, and unfortunately, he passed away 2 months ago. He actually was on my PhD thesis committee. We have a lot of fond memory about that, and I'm sure he will be missed dearly. In our assay, 3T3 focus assay, we relied on a so-called NH3T3 cells. And this cell line was initially established by George Todaro and Howard Green. And this is a very famous cell lines. And one major character is that it's extremely contact inhibited. So the spontaneous background of transformed foci is very low. And we have to keep it very low because our efficiency of transformation is very low, almost near the background. So we need a very low background monolayer. I was privileged to associate myself with Howard Green in my lab rotation. At the end of 1978, he moved to chair a department at Harvard, and I decided to stay at MIT. But I finished my project, and we published a paper together in PNAS. This example of a border of transformed foci, to my left is a transformed cell, to my right is the NH3D3 background from untransformed cells. And because the morphological evaluation tend to be more subjective, so we perform it in a double-blind manner, just like a wine taste or cake taste. That's the only fair way. Well, this gives you an example of how a typical focus assay look like. You can see out of 12 dishes, sometimes we only have 1 or 2 foci. So the frequency, the detection frequency is very low. But then why we have a MC5-5-0 with such a high number? Because this is a secondary transfection, not the primary. In the primary cycle, usually it's very low. But for some reason unclear, we observed that for a long, long time, and other people observed that too. In the second cycle, it's always higher. We think it's the oncogene get amplified during the transfection process. But this is give you an idea about how we perform the assay in a double-blind manner. Okay, so can this phenomenon be extended to transformed cells from carcinoma or from human non-rodent origins? In this paper in 1981, we discovered that the first transforming activity in human spontaneous EJ bladder carcinoma cell line and in the red neuroblastoma cell lines. And we also reported that the new oncogene probably induced a P185 phosphoprotein. And we should acknowledge Lambo Chen at Harvard and Nancy Hopkins at MIT for providing the cell lines to us. 4 years after I graduated from MIT, because I graduated in 1982, so in 1986, Min-Chi Han and Cornelia Bachmann from Weinberg's lab, they cloned the new gene and they found the new oncogene actually is related to the epidermal growth factor receptor protein. In 1987, Dennis Schleman has a major paper that he found the HER2 new actually are the same gene, they're related. And earlier, Yamamoto actually also found CERB2 have gene amplification in salivary gland adenocarcinoma. But salivary gland adenocarcinoma, after all, is not as common as breast cancer. In addition, I think Yamamoto has not really made the connection between our new oncogene and the ERB2. But I noted that we have Mr. LB2 here from Xinjiang Kang. I think earlier in his career, he also worked on CLB2. So anyway, later on, they found these tumors express P185 and exo-auric from Genentech. They make the Herceptin, which can be used for diagnosis, for example, for the triple-negative breast cancer or for therapy. And many breast cancer women got treated. And so in 2019, this team received the Lasker Award. And even today, there are still a lot of combination therapy clinical trials with checkpoint inhibitor or drug antibody conjugation. So despite the success, we are criticized for a lot of things, like NH33 is not diploid, and they are not Homo sapiens anyway. And the calcium phosphate transfection method is kind of a dirty trick. And so we need to do more. So to rigorously prove that there is a cellular transforming gene, we set out to isolate the gene from human EJ bladder carcinoma cell line. And this is the cloning paper. Now, the cloning strategy is based on the fact that human repetitive sequences and mouse repetitive sequences are not conserved, meaning they do not cross-react with each other. And so the green dots get diluted after serial cycles of transfection. Now, the southern blot is an example. The first length primary transfectant, you see smearing signal because there are many repetitive sequences from human genome. But after another cycle of serial transfection, most of the irrelevant human sequences got diluted. Only if those repeated sequences are closely adjacent to the oncogene, then they survive the serial dilutions. So this is a very simple strategy. And we make a phage lambda library from that 1.6 kb fragment.再往上，再往上。OK， 这张可以，好 ，OK。Sorry。下一张。OK， 下一张看看。Okay, so as you can see here, as expected, after the cloning, the plasmid DNA shows like 10 to the 4th to 10 to the 5th enrichment in the transforming activity. Before, in each experiment, we need to use 75 microgram cellular DNA to see only 1 or 2 foci on each dish. Now we can use 1 nanogram, and we get. 哦，好 ，OK， 好，下一张。Okay, in Weinberg's autobiography, he has a statement that Shih, on the other hand, moves steadily ahead with his own strategy. And I was often asked by students, what does it mean by his own strategy? And this is the ECHO-R1 strategy. It involved complete digestion and partial library, while at that time, the most trendy strategy is to make a MBO1 partial digest and make a complete library. And that strategy was favored by many people at that time, including Jeffrey Cooper's lab by Ted Quantirius, or by Benjamin Shih in Bob Weinberg's lab. So I'm not doing anything popular, but it works. Okay, so we did detailed analysis by restriction endonuclease mapping and Southern. We cannot find any major structural difference, no apparent difference. So we think the difference must be very subtle. But we did find that there's a normal counterpart of the EJ oncogene present in human diploid fibroblasts. So that basically provides some evidence to support for the proto-oncogene hypothesis by Mike Bishop. And soon after the cloning of EJ oncogene, we found that actually it's related to the Harvey sarcoma virus, Ras genes. And by DNA sequencing, it was found that amino acid 12 has mutation of G12C in EJ. 回去 ，yeah， 好，这一张。So time flies, 40 years passed. Now we have a undruggable period. Now it becomes so exciting that so many people working on combination therapy, drug resistance mechanism, pan-RAS inhibitors. And I entered the keywords, so thoracic, and I come up with 551 papers over the past few years. So it is exploding, and I think it's a very exciting area. Now, last month, in Science, there's a paper that about covalent inhibitors of PI3 kinase RAS binding domain impel tumor growth driven by RAS and HER2. So the earlier paper in 1981, we found RAS and HER2, and this is really last month is like a two-bird, one-stone strategies. And next slide. Okay, I would like to thank Peter Russell for crediting me. They cited my name and Weinberg and the index. Next slide. And Suzuki did the same thing. In the text, he cited my name several times and also indexed my name. Next slide. Also, I would like to thank Mike Bishop for graciously crediting our work. This is taken from his autobiography. Shih and Weinberg provided dramatic additional evidence to incriminate proto-oncogene in tumorigenesis. So I would like to thank Mike for including our work. Now, Jim Watson unfortunately passed away a few weeks ago. He once visited Taiwan 10 years ago, invited by Chiaho Wang, the then president of Academia Sinica. And there's a long line of his fans waiting to collect Jim Watson's autograph. I did the same thing. I know, 不能免俗. I was in the line and waiting for a long time. Finally, it's my turn. I asked him to sign. He never asked me why he has to sign his name on this page. And I never bothered to tell him, you're using my data. This is the last slide. And I never told anyone about this story. I never told my family about this either. But this is the PhD diploma from MIT. The title reads like this: Cellular Transforming Genes from Chemically Induced or Spontaneously Arised Tumor Cell Lines. Well, I submitted my version is arisen. And this is grammatically incorrect. So after I passed my thesis defense, Weinberg was very upset. I said, well, he doesn't want me to pass the defense or what? He looked very upset. Then he said, do you know your title, the first page? You don't need to open. It was just, it's arisen. He said, David Baltimore and Phil Sharp, they are laughing at your English. I say, well, they are laughing at your Pittsburgh English. He's from Pittsburgh. Because I put the thesis on his desk for at least 1 month. And it's sitting there because every time I try to steal coffee from the office, I pass through his office and my green cover thesis was sitting on his desk. So I really, but anyway, I think this is my fault. It's not his fault. Now, the choreographer probably sensed that there's something very wrong with the English. So he is so smart, he changed that into arise. So I look up the dictionary. There's no such word. The past tense is arose. You can find it in Webster Dictionary, arose, but there's no such word as arise. So the choreographer, for some reason, has the inspiration to create new words. But the correct version should be arising. And this is the first time after 40 years I reveal my true story. I still have my diploma in my office, and I consider that is not a bad looking birthmark. I think this is another slide, if I can. Next one. Oh, yeah, this is just acknowledgement. We thank the funding agencies for all 3 papers. And I added Peggy and Nancy Hopkins. For some reason, I don't know, their name got left out, but it's my fault because I'm the first author. Peggy, I don't know her name, but she always wears a small sweater, wearing golden glasses. And I'm very grateful for her generosity to provide me the red neuroblastoma cell lines. Unfortunately, I don't know her name. But anyway, this is about my story. And I'm really looking forward to learn more about the exciting research in the RAS inhibitors. Thank you very much.
Okay, that's great. So right now we open for the question because time limit. Is there anyone? Okay, Professor Gong.
Yeah, Chiaho, you know, at that time I was at Mike Bishop's lab, right? I just graduated. I just had a postdoc at Mike Bishop's lab at that time. Okay, so anyway, so it's not a question, but so I think many people associate Min-Chi Hong with HER2. Okay, thought his grandfather or father of HER2. My thinking is that you should be the daddy of HER2. He is only the uncle, right? She just cloned the human one, and you were the one to discover the red oncogene first.
Well, thank you for the saying that. Actually, the paper was published in 1981 in Nature, and I think it's just a shame that Bob Weinberg never really spent the time try to humanize the monoclonal antibody. If he collaborated with a guy called Mark Green at Harvard, and they have mouse monoclonal antibody. If they could have humanized earlier, then the Herceptin business, a lot of it will go to MIT. Yeah, but you know, you never know.
Okay, so another question. Do have the question, but you can answer in private later on.
Oh, okay.
Because why Bob Weinberg didn't win the Nobel Prize? Okay, all right. Let's give a bigger round of applause to Professor Shih. Thank you so much.